Alright, so here's problem 1. So the way that we have to do that is we have to look at the expected value of x formula. So that's from negative infinity to infinity. This is actually not taken literally. This is only speaking for the function itself. So in this case, even though it says negative infinity to infinity, the actual problem is just going to be from 0 to infinity. And then it's x times the function, or the probability function of x, which is all of this. So x times that from 0 to infinity. Okay, so now let's take a look at that. So we're going to write out the integral from 0 to infinity of x, let me write that like that, x times 1.4 e to the negative 2x plus 0.9 e to the negative 3x with respect to x. Okay, and now we're just going to distribute, so bring this x into this and to this, so that now we have, and I'm also going to break this integral up because it's being added here. So what we're going to have then is two integrals. We're going to have the integral from 0 to infinity of 1.4x e to the negative 2x plus the integral from 0 to infinity of 0.9x e to the negative 3x, and both of these are with respect to x. Okay, so now if we think about this, normally with e functions we look at this and we try and create a U-substitution, but unfortunately we can't do that because of this x here. So this actually is an integration by parts problem. And so what I prefer to do for both of these is to take these out of the problem. So we get 1.4 integral from 0 to infinity of x e to the negative 2x dx plus 0.9 from 0 to infinity x e to the negative 3x dx. Oh, and that's supposed to go down there, but okay, so now, like I said, this is integration by parts. So the integration by parts formula is the integral of u dv is equal to u v minus the integral of v du. So this is integration by parts. So then we're going to have to do this twice for this and for this. So then this then, we're going to let u, and typically you let u be the one that can be differentiated the easiest. So x can be differentiated very easily. So we're going to let u equal x. And then we're going to let d of u, so the derivative of x is just d of x. And then d of v is going to be e to the negative 2x. Now I'm going to skip a step here because I don't have room, but you should look up how to integrate, which is what you're going to be doing. Since this is dv, then we have to make it v by integration. So you're going to have to integrate this, and basically that's a U-substitution for this, which would be negative 2, and then you take it out to the other side. So it'd be v, okay, equals negative 1/2 e to the negative 2x, just like that. Okay, and then apply the integration by parts formula. So uv, that's negative x over 2, since we're multiplying them, e to the negative 2x minus the integral of v, so that's negative 1/2 e to the negative 2x with respect to x. Okay, now at this point, we can just pull out the half. Okay, and now this type of integration, like I said, this is a U-substitution, so this is going to be negative 1/2 e to the negative 2x evaluated from 0 to infinity. So at infinity, it's just going to be 0 because we have the infinity up here, and so that's going to actually cancel out. So then that tells us that that's going to be 0 minus negative 1/2, but then e to the 0 power is just 1. So it's actually just going to be negative 1/2. And therefore it's just 1/2. Okay, and now we need to apply this same interval from 0 to infinity over here to this. So then we're going to have negative x over 2 e to the negative 2x evaluated from 0 to infinity. So like I said, infinity zeroes it out, minus, but then 0 over here, that's just going to make it 0 anyway. So it's just a half for right now. Okay, now we need to apply the same principle to this one. So looking at this one then, let's see. Oh, I'm sorry, but remember, and don't forget this either, is that this 1.4 has got to come back down here. So this is actually times not 1/4, but actually times 1.4. Okay, and now back to this. So then do the same process. So let's create u is equal to x, and then d of u is equal to d of x, and then d of v is equal to e to the negative 3x. Integrate that, so it becomes v equals negative 1/3 e to the negative 3x. And now just do the integration by parts. So uv, that's negative x thirds e to the negative 3x. So that's uv minus the integral of v, so negative 1/3 e to the negative 3x, and then du, which is dx. Okay, then let's start simplifying this more. So then this stays the same, but this is going to become plus 1/3 integral e to the negative 3x dx. Okay, and then from here, do a U-substitution again. So then this is 1/3. Ooh, good thing I noticed that. But look at, going back to this, okay. We had pulled out the half from here. And then when we brought this down, it came out to be this. So it looks like it's just a half, but do not forget to multiply by that, because that's what we took out originally. So this half comes from this, which, you know, simplified to just a half. So actually we got to make sure we multiply an extra half in there. Okay, now apart from that, we go back to this. This is 1/3 times, and then remember this, this is going to come out and become negative 1/3. And then let's do e to the negative 3x from 0 to infinity. So infinity zeroes it out, so it's 0 minus 1, essentially. And then if we distribute the negative 1/3 into that, then that's going to be positive 1/3, so altogether that's 1/9. Okay, and then this one, the same thing applies here. When we do from 0 to infinity, infinity zeroes it out, and then 0 also zeroes that out. So we have 1/9 times 0.9. Okay, and so now all you have to do is we're going to get our calculator out, okay? And we're going to say this was 1/2 times 1/2, which is 1/4. So we're going to do 1/4 times 1.4. And that gives us 0.35. But then for the other integration, that's 1/9 times 0.9. And that's 0.1. So then 0.1 times 0.35, or I mean added to 0.35, gives us 0.45.